Hi, colleagues. First of all, thank you very much for selecting my presentation. I really appreciate you for coming. Today we are going to talk about no-garbage techniques for low-latency Java. Before we jump into the topic, briefly about myself. I'm Ivan Zverev. Currently, I'm lead developer in EPAM. Last 3 years, I'm working in low-latency projects, and overall, I have 9 years of experience in IT. From personal life, I love 2 kids, 2 huskies, 1 wife, and and my hobbies are chess and Hearthstone. Yeah, and you can find me on Twitter in Ivan Zverev, like my name, surname, easy. Okay, what we are going to talk today. First of all, we will discuss what is low latency. Then we will speak about where low latency is required, domains, project types, why using Java for low latency projects, why no garbage, why garbage is that bad for low latency, and finally there will be some no garbage techniques. And Q&A session. So let's start. First of all, low latency. Who has ever worked in low latency projects? Please raise hands. Okay, so we have both. We have people who worked and people who didn't. So to be on the same page, what is low latency? What is latency in general? The best example to illustrate that is Pavlov's experiments. Yeah, so we have some stimulus, we have response, and the time between stimulus and response is actually latency. I'm trying to avoid here the naming request response because it mainly reminds us about web services, and definitely we can measure the latency of web service call, but low latency is not only limited with this. So it can be some method function call, it can be a GMS message, reaction to it, something like that. It can be a remind call, whatever where we have stimulus and we have response. And actually, what is low latency? To illustrate that, I also have a story. Imagine a guy who is in the desert, he's thirsty, he's dying, and finally he finds the lamp with the genie, and he rubs the lamp, and genie appears, says, what do you want? And he says, I want home. He says, okay, no problem, let's go. And he said, no, you didn't understand. I want home fast. He said, okay, no problem, let's run. So actually, what is low latency? It very much depends. Mainly, if you look at the project's non-functional requirements, you will see what exactly for this project low latency means. And what is even more important is that it should have some measurable objectives. We will talk a little bit later what are those measurements, what are those metrics. But if you cannot calculate what is the latency, what you are measuring, then you will have problems with defining what is low latency. Just to give an example of low latency in high frequency trading, for example, there was a statistics from 2014. One of Canadian exchanges published that 11% of all their orders were completed, were like closed in less than 1 millisecond. Just to compare, when you blink an eye, it takes 300, 400 milliseconds. So while you blink an eye, someone was already closing 300 orders. And if we started speaking about high-frequency trading, it's good to speak about what other domains are really important for low latency. High-frequency trading, online gaming. Definitely when you're running with some gun, you don't expect it to be lagging, right? Betting and bidding. During the match, it's very important for these bet companies to react very fast on the events, because otherwise, let's say this latency between the event happened and it was shown in the system, there could be really arguable situation with their clients. Video chats. Vehicle autopilot system. I guess everyone expects them to be very, very... Okay. Okay, okay. Yeah, we have one more. So let's now discuss the metrics. Just reminding you this slide. What we are measuring when we are speaking about low latency. First of all, this is maximum latency, and this is the metrics which was heavily targeted by G1 and Shenandoah garbage collectors to reduce the stop the world pose. Actually, what is maximum latency is that when you shoot to the system like 1 million of requests, and you see the final result, and the biggest time which response took, it's actually maximum latency. And the average latency is quite clear. Yeah, it's average. Small spoiler, yeah, both those metrics are affected by garbage collection, and that's why we are speaking now about no GC, no garbage techniques, in order just to avoid that. And if you're speaking about that, what actually can influence on the latency? I had a big discussion with my friend when I told him my topic of this presentation. He told why you are doing that, why you are trying to solve these small issues when, for example, call to database can take much longer. Yes, of course it can, but usually if you are working in low latency project, those problems either solved by someone else, or they are somehow eliminated, or you have to work with them. So you will have to solve them, and finally you will get to those which are, let's say, less important. So actually, what can be? It can be slow external resources like database. It can be ineffective algorithms in your code. It can be improper used data structures in the code. And communication channels. Finally, it can be JVM. And I put asterisk here because with JVM, it works both sides. Because JVMs really optimizes your code, and it's making it much, much faster. From the other side, yeah, when we have garbage collection working in parallel, it consumes resources, and this can slow down your system. Why we should select Java for low latency? And to illustrate that, I've used quite popular tweet, which was popular like 3 months ago, about armed robber. So imagine situation, there is armed robber who is coming into my house, and I'm hiding under the bed. And armed robber, and I'm keeping quiet, and armed robber, and I'm still keeping quiet. And then he says, Java is not suitable for low latency projects. And I'm, come on, Java can be almost as fast as C++, and it has tools and libraries, infrastructure, all that. Oh. So why Java? First of all, it's wide ecosystem. Yeah, so Java is not only the language. It has tools, it has libraries, it has monitoring systems, and everything. Like, as Java is one of the most popular languages, they are really well integrated with it. Speed of development. Let's compare. We have a team of Java developers, we have a team of C++ developers. If they are on same level, most probably they will be progressing with business requirements faster. More smooth hiring. Again, if we consider that we can write something on C++ which will be working faster than in Java, those should be really cool C++ guys. And actually, to hire them, for our recruiters, it could be a problem. So with Java, it's a little bit easier. And speed of code. The times when Java was considered like totally slow comparing to C++ to C, they are really, really far in the past. Latest optimizations which JIT is doing, how JVM in general is working, it makes it almost as fast as C++. And you should be really, really cool in C++ to write faster than in Java. Actually, here we should stop for a small discussion. Do you have any questions to the first part?
of any kind of standard containers algorithm. So it's actually kind of C coding in Java. Why not just use straight C?
This is what I was.
It looks like a Vrock too for the
Yes, and I had this discussion again with my friend. Finding C developers is hard. Actually, integrate what companies already have, yeah? So they've bought huge amount of licenses, tools, whatever. So it is much easier integrated with Java. And actually, you're right, but still, for me, I was also working in such kind of project where from all the dependencies, we had only JUnit, and that's it.
It was a trading.
Okay, so clear.
We were forbidden using anything from standard Java, only our own internal framework with this operating system.
Okay, and this basically still, for me, as a Java developer, yeah, this is just personal opinion. I'm Java developer, yeah. I'm looking at this code and I can understand it. That's basically it, yeah. Thanks. There was another question.
Yes, my question was about, so when you code towards the legacy environments in Java, I got a gut feeling of mine is that the programming paradigm you're going to follow is different. And it has something to do with just my statement that hiring Java developer is easier compared to hiring C++1. But I think that when you really have to code against load balancer environments, your code in Java will be looking mostly like native code in C++ would write. So I mean, when you have this like a certain environment to be of your code to be super low latency, I think. I mean, the way you code is kind of different. You have to build a certain expertise. This probably has something to do with how C++ developers would probably design this kind of code, right?
Okay, my answer here will be that actually automated memory management and garbage collection in Java, this is just one part of the tool. Yeah, so avoiding that doesn't mean that we neglect all other principles of the language or other principles on which we are building software. So this is just one thing which we want to avoid. Of course, it has trade-offs. Yeah, definitely. If we are speaking about that we are going to modify our code to be more efficient, definitely there will be trade-offs. Yeah, but it doesn't change for me how I have seen it. It doesn't change the paradigm. It's just it's different techniques which you actually need to learn, and then when new people are coming to the project, you need to teach them those techniques, and you should review them more thoroughly because in the beginning they will not be following that. But for me, this is not a change of paradigm. This is just, let's say, not using one of the features which was provided. Yeah, we never use 100% of the features which are provided by the language, for example.
What about no garbage?
What about?
So functional programming, for instance, promotes the use of immutable right? There is a reasoning about that. If you do so, you potentially generate a lot of garbage.
Yes.
And my understanding that when we start speaking about low latency, we kind of in this situation where we prohibit it to do so.
Mostly yes.
This is what I meant by saying shift of thinking of paradigm you're going to program again.
Sure. So the initial question was that does NoGC coding change the paradigm of development? This is one thing. And second thing, should we avoid functional programming because it is based on immutable whatever, on immutable state of objects, and we are duplicating that, and we are triggering garbage collection more often, by the way. And actually, this is what I'm going to tell further, that basically, yes, this is the, when you start to do no garbage coding, mutability becomes like your one of the best friends. And this also means a trade-off. Yeah, so if you are going to do it in concurrent environment, then definitely you will need to synchronize that. Thank you. We had two questions. I guess we need to proceed. Thank you for questions. So, the first techniques I'm going to discuss is the most controversial one. It's singleton. Singleton actually is the pattern which restricts instantiation of the class to one instance. And you should never... Who considers that singleton is the anti-pattern? Okay, who considers that singleton is pattern? Who considers both? That it is both? Okay, I should agree that it is both, but from my perspective, if it is widely used, and it is, then definitely it's a pattern, and it doesn't mean that it shouldn't be anti-pattern as well. So benefits. We are using one instance across the whole system. And we are reusing this along whole time of life cycle of the application. We instantiate it once, and it's going to work for us for a long time. And actually, another benefit of singleton is that you actually, it controls the instantiation of it itself. So we have flexibility here. And trade-offs. Actually, testing. When you have singleton, you will have problems with testing, and you will need to think about them. So in many cases, tests will not work just sequentially. They can give different results. So you need to keep that in mind. Dependency hiding, which is going from this instantiation flexibility. Yeah? So when the person is creating the object via constructor, it is passing the arguments there and see what this object was dependent on. When we have singleton, this is hidden by the implementation. Class loading. Actually, classic implementation of singleton guarantees only one instance per class loader, not per JVM. And if you have several class loaders, you need to also to think about that. And as well, deserialization. So classic implementation doesn't guarantee that during deserialization you will have only one instance. You can have many. And actually, I wanted to show the enum implementation of singleton, which was, I don't know, invented or described in Josh Bloch Effective Java book. So basically this implementation solves the deserialization problem because this is enum and it will be deserialized only once. Next technique, second one is flyweight. Flyweight actually is a pattern which uses some caching mechanism to avoid instantiation of big amounts of objects. It's better to see an example. So we have some cache map. Let's imagine that we are building some planet system. So we have planets cache, and we have static method getPlanet, where we pass the name of the planet. So first, what we are trying to do is we are trying to get it from cache. And if it is not there, we put it in the cache and return. So let's imagine this call on 1 million calls, yeah? For 8 planets of our solar system, in this pattern, we will create only 8. In million, we will create every time new planet. It's quite expensive. So main benefit of flyweight is reducing memory consumption with this caching mechanism, and trade-offs actually is additional code complexity. And the ones we have mentioned, discussing the immutability, that actually, if you are going to share that, definitely those objects should be immutable. Precise collections, very, very easy technique. I will give immediately how it looks like. So when you're creating some collection, you just provide the initial capacity of it. It can save you some memory, but as additional benefit, what you will get is that if collection is quite big and you will precise it immediately, it will not reallocate every time the memory when you will be reaching the threshold. So for low latency, it's also very, very important. So benefit is allocation memory and avoid reallocations. And trade-off actually that you will need to think a little bit in advance when you're creating the collection, what should be the size of it. So some additional analysis. Using primitive type collections. So everyone knows that for standard Java collections, you cannot put their primitives. There are special collections which were created not to have this possibility. For example, Trove, Apache Commons primitive, high performance primitive collections. Main benefit of using those collection, of course, is saving the memory. We are using primitives. We are not creating every time the wrapper for standard ints or something like that. Trade-offs is actually using external libraries. It's additional risk. We don't know how it was tested. We don't control its development. And maintaining extra dependency. For some low latency projects, as we were discussing previously, adding a new dependency is in general a problem because people just don't want to use something which they don't control. Using string builder, very easy technique. Everyone knows it. Mainly, it just helps to work with the immutable string, so avoid these concatenations and. Just using string builder instead of strings, in many cases, will save you a lot of memory. Enumerating constants. Actually, quite exotic technique, and I don't know. From code perspective, maybe it doesn't look very good, but it really can. When you have really a lot of those constants, first of all you are saving the memory on the ints. And second thing, operation on ints will be faster than on strings. So if you have like predefined amount of string constants, you can use them like that. And actually, there is opinion, and actually I agree with that enums will be more suitable in this case. I would agree that it looks more concise. Still, the approach with enumerating constants has its own benefits as well. First of all, yeah, for here we are making the comparison. So enums are really more laconic, but enumerating constants, you can actually enumerate things which are not related one to another semantically. So when you are using enum, it should be grouped, yeah. So it has some name, and you cannot just put some random things there. And with enumerating constants, you can actually. Second thing, when using enums, you should be very careful with its values method, because every time when you call it, it will create a copy of the array of those elements. So it doesn't return all the time the same array, it will create a clone. Guarding memory allocations. This is already, those names, actually they are not official. Yeah? I named them somehow. I need it. So example without it. Yeah, so we are doing logger debug and concatenating like 3 strings. And here is we are guarding. So if log level is debug, then only then we call this operation. What we are doing here, yeah, is actually when we do logger debug, it will call the method, and inside it will check if we have log level enabled or not. And in most of the cases it will be not, and it will have to exit. So, but still, we already made a call, we already concatenated strings, we already created them. Why? And actually, the last technique, which is very generic. So you can create any class being with reusable object, and actually, this is the object where you can reset the state anytime with simple method call. Benefit is actually that you are saving memory on allocating the objects, and trade-offs, you automatically make it mutable, and you start to deal with concurrency. Here is something like it should look. If we want to create some star system, we need to provide it star, we need to give it planets, for example, with the setters. And at some moment, you just do reset, you can put them to null, or you can have some other conventions. For example, you can empty the planets, or whatever. This is already like according to your conventions. And this is how this reusable object looks like. And of course, we should understand that when you reset it, there could be some flag or whatever. Is it in the reset state or not? But it already depends on how you would like to implement that. And actually, here is our summary. What we have discussed today, we have discussed singleton, we have discussed flyweight, precising collections, primitive type collections, string builder, enumerating constants, guarding memory allocations, and reusable objects. I hope that you find something new for you, and you will be it's easily possible really to extract this and to put in your projects straight away, even if you're not in low latency. Thank you, and another set of questions. Definitely during the initialization. So in that project where we had really strict memory garbage collection rules, garbage collection was allowed during the initialization phase. So initially, we create like objects, we do all the init stuff, and then then actually every full GC was considered a production incident. So in the beginning, we do all the or did I understand your question correctly?
You're going to have on the JVM, you're going to have the hotspot recompiling or not recompiling, but like the interpreter is going to compile your code, right?
Right.
Right. So my question is, are you fighting against this by, for example, running it for so many times that it actually gets compiled before you turn it on in the production? So basically keep it warm enough to be ready for production and to be fast there, not recompile it. Or do you do anything else to get rid of that problem?
I didn't get why compiling should be a problem in this case.
I'm not saying it is a problem. Actually, the problem is the other way, when it's going to be interpreted at the very beginning.
Okay.
Because
During the initialization phase, we have this because for server it's like 10,000 should be run. So there is a run of these things during the initialization. So when you start your server, it's already warmed up. So it's yes. Question: did you try Graal VM? No, I didn't. Unfortunately, I still didn't touch it and didn't try it. Okay, yeah, makes sense to. Anyhow, there is a sense for me as Java developer to look at Graal VM now.
So my question is regarding more of choosing GC, garbage collector implementation in runtime. So those techniques you mentioned, they apply mostly to the code.
Okay.
But no code is written from the scratch, right? So sometimes you probably depend on some library and so forth, which has some like its internals, right? Which may impact like on your target load latency, right? So when you observe this in runtime, so probably there are some techniques how you tune your garbage collector, which parameters you supply and stuff like that.
Okay. Briefly repeat the question to be it on the Mac. How still, because those techniques were related only to code, how do we tune, how do we select garbage collector? Actually, as I told, for us, garbage collection is prod incident. And we predefine everything and it shouldn't run for us, yeah? For initialization stage, we have G1, but on standard settings, because like during init, we don't care really. much, and then it doesn't run. But actually, this was the intention here, to show only the coding techniques. Yeah, so I was not going into the details with JVM flags, with the tuning. This is separate topic which was not scope of this presentation. That's why I was not speaking about that. But answering the question about how do we use it in the project, we don't. It doesn't exist. No, it's not part of the incident, but it's desirable also to avoid that. Yeah. Any other questions?
You were saying that the push GC is a product incident. So do you do something to avoid it? Like you monitor the memory consumption, and when you see it rising, you do some stuff?
Yes, actually, there were. The question was, do we do the monitoring of garbage collector, and do we do monitoring of heap size? Actually, definitely monitoring of garbage collector works. So we have enabled options for printing the GC. And the second thing is that actually, for now, I'm not sure if we print anything about heap size, because actually those techniques, the project is quite old, and now it's in support phase, and we are adding something. Really, we know that it definitely in test environment we do load testing, and we could see if the garbage collector will be triggered. So we don't have any tools for monitoring the heap on the runtime.
Is that all? Or not, maybe? Any questions more?
No, no. And actually, we don't use concurrency. It was the project where, by design, every service was designed as single-threaded to avoid overhead on synchronization. So.
Okay, so that was Ivan Zveriev, and thank you very much, Ivan.
Thank you.